Good afternoon. I hope you guys have had a great day so far. And so far, I'm very proud and impressed with my students since you've come in my room. Let's see what kind of success we've had. I'm not going to go to the equity bars for this because it's pretty challenging and I just want to make sure people are confident expressing themselves. But I will be using equity bars later on. So, what'd you get? I got Stephanie, Kamoy, John, and then Eric.
71.3.
Okay?
71.35.
Okay.
71.35.
So I got 71.35 cubic inches. I would assume because there is a circle involved and that there's pi involved in some of the calculations that there could be variations on 71.35, but I used a calculator with a pi button, left pi in there with as many decimal places as possible until the very end. So any variation on 71 approximately, I would certainly say is excellent. So I already know there's a bunch of you who got it right, and that's awesome. So let's talk about what was key for you. So I want you to think back to the process that you went through as you tried to figure it out. What was a key turning point for you? What was the moment that you found a piece of information that kind of led to things or an idea that popped into your head? Kadir?
Drawing the diagonal of the square to find the diameter of the whole circle.
Okay. When you say square, what are you talking about?
Like the top part of the cube.
Okay. So you're talking about up here?
Yeah.
Like that? Or, of course, it could have been down here as well. That, I must say, was also a key for me. There was also something else that was a key for me that was kind of a silly little thing before that, but I'll get from some other people. So that was a key. And what, I'm sorry, Kadir, what does that distance turn out to be?
5 radical 2.
Yeah, it is 5 radical 2. John, what was the turning point for you?
The same thing for Kadir, and also noticing that the height was the same as the top of the top side thing for the cube.
Okay. Come on.
Yeah, yeah, I think that
Yeah, that actually took, surprisingly, it's like staring you in the face, but for some reason I didn't see it right away, that the height of the cylinder is 5, which means that every side of the cube is 5. Somehow it took me a couple of minutes to notice that, and that plus realizing that I could draw that diagonal and that would be the diameter of the circle were the kind of keys to the problem. But there's a lot involved. I mean, we're talking volume of a cube, volume of a cylinder, area of a square, area of a circle. You need to know Pythagorean theorem or that what kind of triangle comes out when you draw the diagonal. Caleb? Yeah, this is a 45, 45, 90 triangle, so that's a shortcut to get that distance. If you didn't realize that, then you could use the Pythagorean theorem. There's a lot involved. And I must say, that's pretty impressive. That's pretty impressive. And so you should feel very good about the fact that you were able to pull from so many different branches and areas of what we've studied this year. Does anyone have any comments or observations or theories about anything so far? Good. Well, keep up the good work. We're going to pause here and wrap up. So, let's see. So, in the recent past, we've started exploring solids, and we've been focused on the last couple of days on volume. and we're going to focus again today on volume. We're going to shift from prisms and cylinders to pyramids and cones. You will immediately start making connections right away. This is last block, which is shorter. Today's lesson is going to be shorter. It's been designed shorter, and you're going to see that it's going to actually work out perfectly. I've given you a sheet to work with that's on purpose so that you can do work right on that sheet, and we can staple it into our notes later on, so staples can go back around at the end. So, our objectives are to be able to work with the formulas for pyramid and cone. And again, we're talking about volume. So, what are the formulas? Well, we're going to use almost the exact same thing we used for prisms and cylinders, except one difference. You take big B times the height, so the area of the base times the height, but then we're going to divide that result by 3. Because every pyramid, regardless of the shape of the base, and every cone is 1/3 of its corresponding prism or cylinder. So if I were to draw lines straight up from each corner to complete this shape into a prism, and I'm not doing the greatest job, but I'm trying to estimate. If we completed that into a rectangular prism, that would be the volume, big B times height. Now if we slice away this portion and this portion, we are actually slicing away 2/3 of the volume, and we end up with this. And the same thing is true about a cone. What I've noticed in my experience is that the biggest issue is that 1/3. The biggest issue is forgetting the 1/3 or somehow misinterpreting the 1/3 or something related to the 1/3. Any questions so far? So there's not really anything new here, but we're going to use these ideas in more complex contexts. So, example 1, and you have both of these diagrams on the paper I gave you. So, we need to find the volume of this solid. This is a cone. So, the formula is big B, 1/3 big B times the height. You could also write big B times the height divided by 3. It's the same thing. So we have the height right here is 16, so we're missing big B. So we have to work on that. Big B in this case is a circle. What's the formula for the area of a circle that you're supposed to know instantly off the top of your head? Alexandra? Yeah, pi r squared. So pi r squared, so we need r. But upon looking at the diagram, we don't have r. So we got to find it. That's your job? Go. You got a minute. You know how you did it? You know what you did? I mean, like you remember what you did. Good. It definitely was a little bit nicer on the other calculators. So what does the radius turn out to be? I should ask a different question, I apologize. Give me a thumbs up if you've got the radius. Good, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, Kalasia, what does it come out to be? Dianara, do you agree? You got 7.46 approximately? Okay, so it comes out to 7.46 approximately. How'd you do it? Kamoy, what'd you do?
Tangent of 25 is equal to r over 16.
Okay, so you did tangent, let me go down a little bit. Tangent of 25, you said, equals r over 16. Anyone do something different? Just 2 people did something different? 3 people? What'd you do differently, Alexandra? Excuse me, I apologize. Been having a little glitches lately. 16 over r. Yeah, they both work. Anyone do anything differently? Kalasia, you had said different. You did this one, tangent 65. Yeah, that's pretty good either way. I like Kamoy's. I did this one myself. I like Kamoy's because it's just a tiny bit easier to solve. You know, to work it all out. You can use everything in the calculator. But yeah, they both work. So we end up with r is approximately 7.46, and now we've got the trickle down. Now we take the 7.46, plug it in there, crank that out. Once you get the b, plug it in there, and we take the height, plug it in there, crank everything out. So go ahead, you don't need me for that, you guys are experts. It's a matter of punching things in your calculator, and you could probably do it in a way where you don't actually have to stop. You could just punch it in, punch it in, punch it in, punch it in, and you would be able to arrive at the answer. So go ahead, take a moment to do that. So give me a thumbs up if you've got it. Okay, good. Stephanie T, what'd you get? Extol, do you agree with that? What did you get? Okay, that is close. Anyone got something different? Kadir? Okay. Eric, and then over here and then over there.
174.8.
Say it one more time.
174.8.
Okay. Okay. Nathaniel? Okay. Well, it should come out to approximately 932. 932.45. That's what it should come out to. So not sure where the discrepancies are. If you used some rounding of pi, that's going to definitely mess it up, but we don't need to. And we're all using the same calculator, so let's just make sure we're doing the same thing. So everyone punch in 7.46 for me, and then push the x squared button. Now hit times, and now push the pi button. Now push the equal button. Now we've got big B. Now leave that in there. You should have 174.8 blah, 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 blah. Correct? Now we have to take big B, multiply it by 16, divide by 3. So multiply by 16, divide by 3. What's that?
I did times 0.33.
Yeah, you want to try and avoid things like multiplying by 0.33 when you can just divide by 3. Dividing by 3 is much more precise than multiplying by 0.33 because 0.33 is an approximation. John?
You could also put 1 and then the A and B over C button. Then you could press 3 and then mix
That is like the most roundabout way to divide by 3. But okay, go for it.
For dollar, it's just that's a fraction symbol. It's A, B over C. That's a fraction. So you put in 1.
That's actually not the fraction symbol. That's a rational exponent symbol.
That's how.
Yeah.
What is a fraction?
It's just a coincidence that when you punch in a 1 and then, well, I don't know. We'll have to experiment with that. But, okay, whatever works for you, but I just wouldn't want you to get yourself in a position to do something more complex and then that didn't work.
Yeah, but in the calculator on the back, it says fraction.
Oh, is that what it says? Then I apologize. I was pretty sure. I see. Yeah, you're right then. You're right. My mistake. All right, well, any questions? So the key is really just persevering and finding the information that you need to work your way up to the results. Any questions? Okay, so now we've got a pyramid, and the base of the pyramid is a regular hexagon. So this is a hexagonal pyramid. To find the volume of it, here's the beauty of using this method is it's the same. It's going to be 1/3 big B times H. We have the height, so we need big B again. This time it's a hexagon. So how do we find the area? Remember, big B is an area. How do we find the area of a regular polygon? How do we find the area of a regular polygon? We got 2 people who know it, 3 people who know it, 3.5 people who know it. Kadir?
1/2 A times B.
Yeah, 1/2 the apothem times the perimeter. We should be catching on to this, ladies and gentlemen. Remember, I'm going on this journey along with you, and I'm having no issue remembering this. So no more crickets. We got lions in the room. All right, so perimeter, not hard to find. We got 150 is the distance from here to here. So we can calculate the perimeter, but we need the apothem. The apothem is the distance, in this case, from the center of the hexagon to the center of an edge. So we need that distance. So you go ahead and find the perimeter, you go ahead and find the apothem, and then trickle on back. We need the perimeter, and we need the apothem, and then we got to filter our way back. I'll draw in some hints for finding those, and you take a minute.
No.
So, what does the apothem come out to? It's actually pretty easy to find once you realize what's there. So again, I keep making the same mistake. Give me a thumbs up if you've got the apothem. Please. Oh, so everyone's got it. Excellent. What is it? Okay, well there's a simpler way to express it that took no time and no calculator. What was the other way to express it? Sharif? What is it? Yeah, 75 radical 3. Because this is a 30, 60, 90 triangle, so that's x radical 3, and that's 2x. So it's just 75 radical 3. So yeah, at some point you're probably going to have to evaluate the radical 3. But now we can trickle everything down. This goes here. This goes here. That result's going to go here. And this is going to come down here, and we figure it out. If you do things well with the calculator, you can probably get away with not even stopping and writing anything down.
I got 4,579,999.
Can you say the numbers, please? I got 13. Can you say the numbers?
So,
You left the numbers.
what do you get when you do all that cranking out? What do we get for the volume of this hexagonal pyramid? Got one person who got it? I heard a bunch of people just muttering some numbers. Go ahead, what'd you get?
You just say like the numbers or when you say it.
I want you to say the number the way it's supposed to be said.
4,579,909.323 meters, cubic meters.
That's it. This is one gigantic hexagonal pyramid. So, any concerns or questions on how to find the volume of a cone or a pyramid? Anything at all? I'm honestly not 100% sure what is on it and what is not because they've changed it several times. I will look it up this weekend. Next week, we're going to be doing quite a bit of preparation, and that's going to be one of the things we do. Okay? All right. Checkpoint number 1. I'm flipping the script a little bit on purpose. You got 3 minutes.
I did it.
Sorry, bye. You can add another minute.
Just so you know, it's something.
What do you do when you put the radius in here? I did 18. I squared that and I multiplied that by
Why'd you
5.
plug the radius in there? No, wait, this is what I did. I found the area of this circle on the bottom of the base. And that comes out to 1017, and then I did.
Because you could literally do 18 squared times 5 times 1/3, whatever that is. And then you just divide that by whatever it is. And that's the h. This one, you plug all, you cancel all these out, you plug it in. That's the formula.
Because they already gave you
One of them from one.
Yeah, but it's a circle. So it's pi r squared.
But no. Yeah, I got 12.5
All right, now I am going to the bars of equitability. So let's see what we got. What's the height of this cone that we can't even see? I got student number 19, 2, 8, and 21. Student number 19.
Number 21.
Student number 2. Student number 8. Student number 21. So we seem to have massive disagreements. So the correct answer is 12.5 meters.
Happy day.
If you say 12.6, I have to assume you did it right. I just don't know where exactly something. It comes out to exactly 12.5, I believe. So there was a few different approaches. I'm going to share with you what I did. I set up an equation, and this time instead of big B, I actually put in the formula for a circle because this is a cone. So we know that it's 1/3 big B times h. But instead of doing that, I replaced big B with pi r squared. And then I put in the h. And then I set that equal to what I knew the result to be. The result is going to be 1350 pi. We're asked to find h. Solve for h. In theory, you could just divide everything by this. Oh, and I'm sorry, and the radius is 18. So this is not r, this is 18 squared. So we can divide everything by 1/3 pi 18 squared. Or we can do 18 squared, multiply it by pi, divide by 3, and then divide both sides by that result. But there's a simple thing you can do. How do you get rid of the 1/3? How do you get rid of that in a nice, effective, efficient way that does not get us any approximations? John? Yeah, multiply both sides by 3. That will disappear and you get that. Now watch what happens when you divide by the rest. Now 18 squared is 324. I know that because I know my perfect squares. And so I'm going to divide this side by 324 pi. And watch what happens. Pi cancels pi. 3 times 1350 divided by 324, and you get the height. It comes out to exactly 12.5. Yes?
Where did you adjust the radius squared times pi, or just half it and then just times it by 1?
Yeah, I said that. But you also said that you didn't get an answer, right? No. Excuse me. No, I'm saying that you said that you didn't have enough time to finish, right?
Yeah, but 2 seconds later.
Oh, okay. I didn't say anything bad. They're the ones making it sound bad. I didn't say anything bad. Okay. So, any comments, questions? Okay, so I had another checkpoint, but I'm gonna hold off on it, and I'm gonna have it as your warm-up next week. And so your homework is page 766, number 6 through 22, and 36A and B, which works out to 19 points total. And then do the at-home tutor for 11.8, and the pages, I didn't write down the pages, so it's the pages for section 11.8. I apologize for that, not having the pages. And your EOC is a little over a week away.